Okay. I'm going to keep it relatively short today because the work is for you to do. That there. Before I get started, did anybody get a chance to pull out the robots and make a move or look at them since last Monday or not? I see not a whole lot of people saying yes, we did. Well, that's all right because now you have to submit an assignment saying that you did that. So I gave you last Thursday to do it. I'll be around this Thursday in the lab to help you, but they're along with next Monday to finish up. So I'm not planning on being out of town or anything. Last Thursday I had some family issues and health issues to deal with that there, but inshallah, my health being what it is, I'll be here on Thursday. But let me kind of go through the assignment. That there, and I did not bring the robot with me, although I do have MATLAB. I didn't, obviously, as my carrying is not good, and the one that's on my desk I still haven't fixed, but this is not it. Hopefully that's not what I posted. Right there, that was another class right there. Okay. Basically, the only thing I'm asking you to do in this assignment is to grab the robot, figure out how to pick something up, move it, and put it down. I'm not giving you any coordinates of where it's at or where it needs to go. You can just do it by trial and error. That's there. The only thing the only goal of this assignment is to force you to actually go pick up a robot, take it into the lab, and write the code for it. So I kind of go through here, and in the lab, I outlined, and I took a picture of actually the robot as it is without the mounting. As it turns out, you can buy this robot, the arm without the mounting and without the Arduino processor from China for a couple hundred ringgits. I mean, out there. Again, there's 6 motors. Just kind of repeat there: the base, the shoulder, the base, the shoulder, the elbow, the wrist, the gripper rotate, and the gripper open and close. So now keep in mind that when we look at a wrist, we're looking at the up-down movement. Again, the camera isn't picking this up. The rotate is also part of your wrist, but I showed it in this discussion as part of the gripper. The human wrist actually has very limited. Normally you use the shoulder and everything else. And of course, since I've had a stroke, I'm much more in tune to what muscles are brought into play on my right hand. But with our robot, if we want to rotate, we only use the gripper rotate motor that there. So I could call that the wrist rotate. In other words, break the wrist into 2 motors. The one that goes up and down like this, and then the one that does the rotate. But the human wrist doesn't rotate very well. But we rotate usually with our elbow and our shoulder and our whole arm, sometimes our body that there. But the robot actually rotates that there. So these are the motors. Each motor can move between 0 and 180 degrees. In other words, I'm just repeating everything I've told you thus far. Where 0, 90, 100 degrees would take each joint. So I'm asking you for the first part. There's actually 2 parts. The first part of this is to just kind of sketch out where 0, 90, and 180 degrees is, so that you have a feel for what your motor locations are. You would do that for each of the 6 motors. So that would be 6 little hand drawings that you would attach it. Next, you determine what motors being set to pick up your object. Again, this is trial and error. Or you can sit down and do this analytically, that this motor has got to be at such an angle. Usually it's a combination thereof. There. And what you have to do is open the gripper, rotate to the right position, lower to the object, close the gripper. Remember not to completely close the gripper. This is the key one here on that there. If you completely close the gripper, you're going to ruin that motor. You close it enough just to pick it up. There's a little bit of spongy rubber material inside that gripper. Just get it enough to pick it up. And don't pick up anything large. My estimate would be, for the ladies that use fingernail polish once in a while, you know how big a fingernail polish bottle of fingernail polish is, right? Guys, go to the store and see how big a fingernail polish is out there. Or a tube of airplane model paint, the little tiny paint things you use to paint here. But something small, that there. You start getting into, you can pick up a piece of candy, that there. You can pick up, I don't have anything small enough here handy that there. You can pick up, for example, this might be a little hard to get a grip on though, something like a thumb drive, but nothing ain't bigger than that there. Don't try to pick up a can of, a 50-pound bag of rice. This this little robot obviously can't pick up more than about, 100 grams or more. It's fairly delicate there. So there, raise the object, rotate to show that the gripper is working, and then place it back down, open the gripper, and then move the arm away. That's all I want you to do is reach down, pick something up, rotate it around, put it back down, and move away from it. That's it. That's all you have to do for this assignment. Obviously, it's going to take you several hours to do this because you haven't touched the robot yet. That's why, it's really interesting. Okay, all programs are done in MATLAB as an M file. So if I bring up MATLAB, and hopefully it works, right there. MATLAB, right here. And that was the problem I had a week ago. I couldn't get MATLAB to run on this computer. So I went and got an older version. It doesn't matter how old the version is. Right there. What's that? License. This version doesn't need a license. Out there. But yeah, we've got a licensed version in that lab. If you want it for your computer, then just look around. I might have I don't know if I've got a copy out here. I think I've got a copy upstairs on my hard drive, but I won't be up there this afternoon. If you need a copy of this version, see me upstairs tomorrow morning. I've got class at 12:30, so 12:15. So come see me sometime before noon. I can get you a copy of it. There's all kinds of copies of this floating around. So I should post this on Facebook or my YouTube that we're using, but okay. Now, in order to do this, what you need to do is you need to do a new script, right there. New, and this is a script. Now I'm going to cheat, and I am going to copy. Now, obviously, you need to delete my text here. But this kind of gives you a starting point right there. So This opens S, which this will not work. I didn't bring a robot with it there, but opens the serial port for communications right there. But there, this is COM3. I think if I recall, the one the other day connected at COM3. So this is COM4 right there. I have a little note. This needs to be the COM port, and again, my note doesn't. Let's do a save as. And I'm going to call this junk M right there, because I actually have in here a test one. Oh, okay, that's something completely different. All right, we won't get. We'll bring junk back up there. So the steps are, and again, we covered this in a previous lecture, and I posted the file up there, I think, didn't I, earlier for the test program. It tests all 6 motors right there. But the first thing we do is we open the serial port, and you have to hook up the motor and go through and check to see which port it is. Right there. We set its baud rate. So actually, I said that the wrong way. First, we define the serial port as, we're saying S is a serial port. S now is a variable. We write to it. We're writing to the serial port right there. We set its baud rate to 9600. You can go into the setup mode of your PC and change it to 4800 or something. Don't do that. Just keep it at 96. Why change things that work perfectly fine, right? At this level, that there. So we open it. Again, I stick some pauses in there simply because my old computer didn't seem to keep up with it, and I think this one probably would be even worse. The computer's actually too fast, and the robot, the Arduino, is just way too slow. That there, so we have to put some pauses in there, and then we set the speed. So the speed is somewhere between 50 and 112, and 92 happens to be about 80%. Now you can lower that 92 right here to say 80 or 70 or something like that. If you want to make it slower, you can try speeding it up to say 100 to see that there. I find that if I speed it up, it tends to not work right. These robots that there. Again, I'm sticking pauses in there, and here I'm moving the base from 0 to 180 degrees, right there. While moving servo to 180, I don't know where it's at to begin with, right there. Then I close the serial port. Right there, close. Now, one of the things that will happen, and I didn't, I'll be real honest, I didn't order these robots. I didn't write the software for them. But what I have discovered is that they will lock up, and the only thing you can do is unplug the robot from the computer in the wall, restart MATLAB, and start over again. You don't lose your code, but you have to reestablish the connections. The connections just get hung up. Something about the Arduino, it doesn't close the port properly. And that's there. And I'm not saying it's a bug in the Arduino software, but that's the most likely source. Again, I'm not picking on the people. I mean, the people that designed the Arduino interface, and that they did a fine job, but it's not, what would I say, consumer proof. They couldn't put it out on the market like Apple or Samsung's do with their phone for the general user and let everybody play with it and break it, because it'll be broken all the time. That they're designing a commercial product that can be used consistently over and over again and work consistently is one of those things you'll figure out as engineers is not easy. It works great on the lab bench. It works great on the prototype. It works great 100 times. You give it to somebody who's not an engineer, and then 5 minutes later they come back to you and say it's broken. That there. And I've worked on projects where we've spent hundreds of hours trying to anticipate every error. We put it out in the field, and within 3 days we get a call from the Navy or the Air Force, whoever our customer is, or some plumber, if it's a heat vacuum system, or some other photographer who worked on a project that copied files from a Sony video camera to a computer out there, and the software's hung up. And sure enough, if we do the same screwy thing that photographer did, which we would never do because we're not photographers, we think like engineers, we know the right way we're supposed to do it, right? It's supposed to work the way we designed it, not the way that a photographer would use it. So the photographer breaks it every time, and we can make it work every time. Well, the goal is to make it work every time for the photographer, since he's the customer. Same thing as if we're designing something for the Navy, it's got to work every time for that Navy seaman that's sitting on the helicopter trying to use the equipment out there. It doesn't help if it works in the lab for us. It's got to work out there over the oceans out there. Yeah, that's somewhat the problem with this Arduino software, is that it probably worked perfectly for them in the lab, and now that we're trying to do different things with it, it's not working every time out there. Obviously, they're a small, I shouldn't say were, I think there's a small 5 or 6 people operation. They don't have a lot of experience doing consumer products. They didn't have a huge budget for a huge, what would I say, troubleshooting and testing operation. And when they first brought the robots here, I rejected all 10 of them. They were junk. I said, take them back. I don't want them. That there. They brought them back about 6 weeks later. I said, all right, well, they work good enough. We can make it do. So, so I know that they're working just well enough to get by. Because the first pass, they didn't work hardly at all. That there. Now, and again, I give them, I respect the guys who went back, they fixed it, they addressed my concerns, and now new concerns have popped up after a year or so of use right there. You saw where I broke the connector by just looking at it wrong. I mean, I was manipulating it, but I'm going to say I was looking. I didn't put a lot of stress on it. It still broke. So keep that in mind as you're working on your projects, is that these robots are relatively fragile. So, and I have just discovered that if you write code and your code is got an error in it and it doesn't work, you're going to have to reset the robot. Because the robot will open this file, start moving, your code goes off to lunch, it doesn't work properly, the robot doesn't respond properly. You have to unplug the robot, and you have to unplug it from both the wall and the computer. One other warning that's not in the lab, but I should point it out, is that these robots can get power from the USB port from the PC. That is an assured way to make sure it doesn't work. Make sure you plug it in so there's 5 volts coming from the wall to the Arduino and to drive the motors. If you just plug it into the computer, it will work some of the time, but as soon as you start moving the motors, depending on if there's any load, you'll draw too much power through the USB and cause the Arduino to just kind of go to lunch right there. So it'll work. I mean, the idea is that you could run it off the 5-volt USB port. Actually, I don't think that was the idea. I think the idea was that you used it always plugged in. But the way they wired the USB to the Arduino, it's tied to to the power line. So as a result, it will power the Arduino and the motors through the USB. And if you had a 6 amp USB port, you might be able to get away with it. One of the new USB-C, wall packs, I think Samsung's got those out for the Galaxies or something. Those might work, but coming off of a PC, especially our older PCs, they can put out about an amp at most. I know I made the mistake. I was using this little tablet here, and I was playing around with it. And I didn't realize it was unplugged. It was working. Oh, okay. But there, then bang. Next thing I know is I feel the USB port on my laptop, and I'm lucky I didn't fry a laptop. That there. I mean, I'm very lucky I didn't fry a laptop. That there. As soon as I saw the thing acting up, I unplugged it, and I realized what I was doing. So, but that's the assignment. I gave you about a week to do it. That's there. Again, I suggest that you sometime during the course. Thursday, I will be up in the lab right there. I'll have my PC with me. And as you're working, you can go work on it at any time. Tomorrow I'll be upstairs, like I said before class. Someone wants to show up with a USB to get a copy of this version of MATLAB is fine. That there, or one of my versions. Hopefully it's a good one. We got so many floating around the office. It's unbelievable. That there, but again, the sequence is just remind you right there. This particular one right here is we find the serial port. We set the baud rate. We open the serial port. We set the speed. That's done at the beginning of every code that we're going to work with. Every move requires 2 lines. One line to define what motor it is, and F-write is a MATLAB command. The write to S, which is our serial port, and we're going to write an unsigned integer that's 8 bits. We could also use a char if we wanted to. We're going to write 0. That defines motor 0. The next line is our angle between 0 and 180 degrees, right there. And then when we're done doing everything, we close the port, we delete the temporary variable, and we clear it, right there. So we have 3 lines at the beginning. We have the beginning part. The beginning is what we define our serial port, how we're going to communicate with it. And then we set our speed, and then you can't change speed, by the way, without closing and reopening the port. Right there. That's one of the quirks of the software, is that the speed is only done one time. If you wanted to make that something you could change every time, you'd have to rewrite the software for the Arduino processor. Right there. What else did I want to kind of point out there? Let's see. There is also an app that you can run these robots using Bluetooth from a cell phone. I found it pretty much worthless in trying to do any kind of programming, but you can do like a one-time move using the Bluetooth app. I don't even discuss in this class how to do it. When I first got the robots, that's the only way we could do it, because the MATLAB interface wasn't working right there. And I required, I think one last comment. You don't have to use MATLAB. You could use Visual Studio or C or Visual Basic or any other programming language to talk to this right here. As you note, the only thing I'm doing in MATLAB is I'm using the serial port. And I'm sending out just commands through the serial port. So I'm opening the serial port, setting a baud rate. That's all same with any language. and I'm sending out the first thing, once the serial port's open, I'm sending out a number that tells the motor what the speed is. And then every other move after that, I just send a motor number and a angle. And I could do that with any language right there, with any type of. So MATLAB is not a magical key here. It just happens to be, we're an engineering program, so we want to make people use MATLAB for something. That's there. In reality, we're not using MATLAB for what MATLAB is intended to do. We're using MATLAB just to send our commands. We could do this easily enough with, we could do it with a Raspberry Pi tied to it, or we could do it with, Visual Basic, or we could do it with C, Dev C++, or anything that will allow us to open a serial port and write to a serial right there. Okay, that's all I had for today. So I said a short day. Sometimes I say a short day and I end up talking an hour and a half, right? Right there. One other thing now before I leave. One other thing. I hadn't quite got that there. Okay. Oh, there. I was going to say I pay $100 a year for that software to log me in. I don't have to remember passwords. Believe me, I've got so many different websites that I can't remember the passwords. I used to have the list taped next to the side of the computer, but now that I do half my stuff on laptops, half my stuff on tablets, everything else out there, I went ahead and got something. There's a couple of them, Dashlane and FirstPass. I did put up here, and I didn't talk about it last time, a video called The Age of Robotics, and it talks about the humanoid robot. I'm going to require that you watch that, and I may have a short little homework problem to go with that there. It's about an hour video, and you can actually download it, watch it, but again, I'm not going to. There. But it kind of talks about the fact that robots are moving into looking more and more and acting more and more like humans, right there. So I just kind of put that up there as kind of an interesting video to watch, right there. And it goes back to that first few weeks of the class where I really spent a lot of time talking about what directions robots are moving into. And this was actually I don't know, just start right there. Let me close some of these things because I'm still editing or rendering last week. But let me just close that there. But it's an interesting video in that it shows the progress we're making in making robots look humanoid. There was one in Japan where someone created a female robot that's, quote, reading the news. And I guess there's other things, but we're looking at that there. I don't look for robots to replace humans in a lot of categories, but as I mentioned earlier, last week or two, Amazon's got stores that don't have people in them anymore that you interact to. They announced they're opening 6 more stores just like it. The first prototype was a success, so they're going to open 6 more autonomous stores where you have you walk into the store, you scan your ID card, you got your shopping cart, you walk through the store, you throw your stuff in the store, and you walk out. That's there. You don't deal with a cashier at all. I do a lot of shopping in the US where I go to a grocery store and they have the self-scanners. And if you've ever seen a self-scanning lane, you know, you walk up with your grocery cart and you take everything out and you scan it and you bag it yourself. And again, I don't deal with a cashier. There's a cashier there to supervise if there's a problem and to make sure I don't steal everything in the store, to make sure I actually scan the stuff. But the whole idea is one cashier monitors 4 checkout lanes out there. And again, this goes back to this video that I'm having you watch. Is one of the ideas of robotics is to eliminate human workers. You know, we don't want them. And that's a very touchy situation because if you work coal mines in West Virginia, and I use the US example, and you're used to supporting families, and they come in with a new piece of equipment that goes down in the coal mine and eliminates 30 miners, and it's operated by one operator, that means 29 people are out of work. That means 29 families aren't getting paychecks. That means that if you have 3 children per family, roughly, you've got 100 kids that are getting hungry every night. That's a problem you got to deal with when you eliminate people. Proton opens a factory in Shalom, and it hires 2,000 workers. Somebody comes in and buys out the factory, and I'm not saying that they're going to do this or if they've done it, but somebody comes in and buys this company out. This is, well, we're going to eliminate 1,500 workers and only have 500 workers and use robots to assemble all the cars. Now you've got 1,500 people out of work. Uber decides that they no longer want to hire drivers, but they have cars that drive themselves. So this video kind of goes into that, and I'll have an assignment for you later to kind of go back and look at this, talk about this video. All right, with that said, let me go here to my record. And this is always a problem. Here we go.